Hello, my name is Thomas Bohn. My colleagues from IBM Cloud Expert Labs and I support companies on their journey to the cloud. The high speed of innovation and technological diversity in this field is both a great opportunity and a constant challenge for my clients and my team. IBM has created the Financial Services Workbench to make the technological diversity and innovative power of cloud native easier for you to manage throughout your company and to fully exploit its benefits. Now, I would like to show you how FSW can help any company to design, build and deploy solutions based on cloud principles from the get-go, quickly and easily and on a large scale. For this, I will take you on a little journey. We'll talk briefly about our common challenges, then about how reference architectures and architecture patterns orient us, and how to manage the implementation and adoption of open source and cloud technologies and methods company-wide. But first, let's talk briefly about the term cloud native. What is that anyway? The term originated a few years ago in connection with cloud computing. The term cloud native is used to describe applications and components that are specifically designed for distribution and scale in the new infrastructures. The promise of such microservices is immense. High agility and flexibility, as well as better availability and scalability. Open source has become the engine of progress here. In order to take advantage of their benefits and high flexibility, however, your organization and working methods must also fit in with them. Which is why the term cloud native today also includes practices and methods such as the well-known DevOps and Agile. But cloud native does not necessarily mean outside your own infrastructure, based on the typical infrastructure as a service providers, what we call the public cloud. A private cloud inside your firewall can also bring all of this into your own data center, helping you modernize your own IT infrastructure. In this environment, quite a storm of technological innovation has been raging for a long time. Today, there are a whole range of cloud infrastructure providers and platforms competing with each other, each addressing different target groups with their own philosophies and approaches. Hundreds of components and technologies have emerged in the open source world that make technology available to everyone. As a result, you can choose from multiple solutions for practically every problem you can have. Many IT patterns have been found and described in the community, which are highly relevant for distributed systems. Among the most known are event sourcing, API first and CQRS. A lot of methods and practices have also been developed to make the best use of the new possibilities. Agile and DevOps are already almost part of the standard IT repertoire. SecOps and GitOps are younger disciplines that are becoming more popular. Business and event-driven, 12-factor up, hexagonal and many others are terms in this area which you have surely heard before. So what's wrong with that, you might ask? There is nothing wrong with innovation in the cloud-native environment. Quite the contrary. It has already brought us all many great new possibilities and promises, and there are even more to come. What is as difficult for you as it is for us? To keep up with the flood of new technologies and to keep an overview and understanding of the possibilities. So we must constantly ask ourselves, what are relevant technologies and practices and which are not for my context? How can they be used correctly? How should I combine and integrate them with the rest of my IT environment? Who are we building a platform for and who can and should use it, build it, operate it, and how? We see problems in the market today already. Lengthy cloud adoption projects that never seem to end. Isolated satellite projects whose tech and method stack do not fit with the rest of the organization. Uncontrolled technology usage across the enterprise. Even though cloud promises to deliver more value in less time. So what's going on? So far, we've neglected a few key points in the technology-oriented discussion in the market. First of all, we must honestly ask ourselves, how can we support the business of our company in the right way? After all, the business people's goals and wishes are not about technology, but rather the digitization of products and customer journeys to provide new innovative products, to strengthen existing ones through modernization, and to make their business model more competitive. How the supporting technology adaptation should look like and how it can look realistically, well, there are many factors influencing this. Most importantly, time to market and ROI goals. Under their pressure, however, factors such as existing personal abilities, experience and work culture are sometimes overlooked, as well as the assessment of how large the gap to the desired target state actually is and how long it takes to close it. My point is, business objectives should always drive the company IT development plan, for cloud native as well as traditional components. The influencing factors should be considered when defining the roadmap. So once what is to be built has been defined, an IT design can be created for it in a coherent, effective and collaborative way. Why collaborative? Since our future systems will no longer be monoliths or silos, we will have systems of systems or networks of cooperating services. These are used to assemble the overall system in co-creation. It is thus essential for designers to master these networks and to collaborate with designers from other areas, divisions, departments, and sometimes even across company boundaries. Ideally, this design should then be quickly, easily and consistently transformed into IT solutions and code that make best possible use of existing and future cloud-native technologies. And this is exactly the mission of the IBM Financial Services Workbench. It methodically supports you in deriving the right IT service modules from your business goals and strategies. It offers a browser-based, no-code tool to define the IT design of these building blocks in a business-like and technically sound way. It supports developers with a low-code programming model for different programming languages, which makes development easy and efficient and allows everyone, especially traditional developers, to build cloud-native solutions. It then consistently uses open-source technologies for the deployment and operation of the services. These technologies were selected and integrated by the team behind the IBM Financial Services Workbench, based on criteria such as suitability for enterprise-level deployment and market relevance. The whole thing then runs containerized in the IBM Red Hat OpenShift container platform. Let's now go on a journey together, starting from the demand for a new solution all the way to the operational service. In order to define suitable solutions for the business, industry reference models such as BIAN, IBM CBM or Accord can provide good guidance. But in my opinion, the best model is always your own, one that you have defined yourself appropriately and that is understood and accepted throughout the company. If you don't have one yet or want to validate yours, well, then it's worth taking a look at the reference models. All models agree that we should no longer build silos and monoliths, but rather independent services that are smaller in size than the systems we built in the past, and therefore are more flexible to implement and maintain. In addition to the technical discussion, it is very important to find the right business granularity for every solution. Because only if it's correct, you will get to sustainable and powerful systems of systems or service networks with reuse. Domain-driven design is a method first described by Eric Evans in 2004. Its strategic level supports precisely this breaking down of a problem space into domains and contexts of proper granularity, leading to the definition of reusable services. The creators of the IBM Financial Services Workbench are convinced that DDD is the most powerful method today for this job and have therefore consistently aligned the platform to it. FSW thus ensures that the modules and services created with it can work together seamlessly while promoting the reuse of existing systems, services and functions. Reuse existing systems? What does this mean, you may ask yourself? What we have talked about so far is to use methods to analyze the architecture of your company as well as reference architectures, the plans you might have for digital platform or customer journeys to identify target components with the right granularity. For each of these components, we then recommend that you ask the following questions to determine the best fitting implementation strategy. Can you buy the function ready to use? If the function does not differentiate you from your competitors, are there good standards, a manufacturer or supplier that can take over development and maintenance? Maybe there is a system that is still good enough. Perhaps it is enough to add some code by yourself to implement additional requirements. Is there a system that is still good enough and you can maybe add missing support by externally sourcing it or with standard software, thus augmenting the existing system? Or do you need a function that really differentiates you in the market, or that you otherwise cannot obtain and which you therefore must implement yourself? You see, not all needed functions should be converted natively to FSW. It is much more important to decide on the best implementation strategy for each component. In order to enable reuse and co-creation, the platform external components and systems that provide functions are linked to FSW according to the service principle, which makes them available for use by channel solutions as well as domain solutions. This reuse begins with solution design because all solutions with all their APIs, domain functions and data models are commonly available and accessible under the roof of the solution designer. Reuse continues with the platform managing cross-solution communication based on REST calls and messaging, and it is also manifested in current operational environments and practices. So you can think of FSW as the Lego plate of the company, as it enables controlled and efficient co-creation and reuse. Let's continue with our journey into IT design. Now that we have defined the new services from a business perspective, we need an effective way to create IT designs for them. IBM FSW brings a browser-based design tool, the Solution Designer, which business analysts and solution architects use collaboratively across project, division, and departmental boundaries. FSW is built on the idea of shared models that allow analysts and developers to collaborate on always current information for each solution. The Solution Designer provides access to shared models at design time with a simple-to-use graphical browser-based application. Two of the most central architectural principles of our platform can be seen in the Solution Designer. Hexagonal architecture, which describes components that can communicate with each other freely and independently of other layers and systems, and domain-driven design at the technical level. FSW's design tool works with DDD's vocabulary to describe solution design. It visually embodies concepts like entities and root entities, factories and commands to describe the domain logic, and APIs, paths, events and agents to specify the external interfaces of a solution. A whole range of modern IT patterns like event sourcing, API first and CQRS are automatically applied and implemented. They are implemented in the platform in the right places, and the solutions you design leverage these patterns. This happens automatically in the background, so you don't have to worry about them explicitly. At any time, a template can be created from a draft solution. Templates allow you to share commonalities and design within and outside your organizational unit and company. A new service based on a template is then adapted in an individual design for a specific use. Both native solutions and individualized templates are then turned into microservices that are deployed in the completely open source and container-based runtime FSW provides. Let's talk a bit about how the platform looks at the highest or macro level. At the macro level, the platform is also hexagonal. That means you will find 3 logical layers to which solutions can be assigned. On top, the channel or experience layer provides channel applications such as internal clerk systems, customer systems on the network and mobile, and partner applications and APIs with their respective specific data view and functionality. On the bottom, the systems layer includes services that integrate peripheral systems and services and serves as an anti-corruption layer for other services. That is, to minimize their dependence on the integrated system. The middle, most important layer, the domain layer, contains solutions that implement business domain logic natively or provides domain logic sourced from external systems and services for reuse inside the platform. Each solution is assigned to one of these three logical layers. So, strategic business design and the idea of reuse is consistently supported by composing services across channels and APIs. Functions are implemented through composition and co-creation. Typically, IBM FSW works closely with systems for business process and API management. Not only are the IBM Cloud-based capabilities, IBM Business Automation Workflow and IBM API Gateway supported, but the platform is also open for working with all other systems on the market. Let's move on in our journey to implementing solutions. The actual implementation of any IT design should be quick, easy, and coherent. Ideally, it allows any developer in the organization, regardless of her background or experience, to jump on board the cloud-native journey with a shallow learning curve and deliver code effectively every day. This helps achieve goals like time to market and makes the IT organization more efficient. For this purpose, IBM FSW uses all the information gathered during the design phase of a solution in a model-driven, rapid application development approach. A term from the 80s, but it still describes what happens quite well. Let's put that in context. The analyst has defined a new solution with the solution designer and checked the design into the repository. The developer now uses the CLI, the command line interface of IBM FSW, to replicate the solution to his workstation for programming. Code generators of the platform are now triggered to create a comprehensive code base from the design information. The developer works with the IDE of his choice to build out the service. This code base consists of the solution framework, which contains all design artifacts from the design phase as generated code. In addition, there is all the necessary base code generated to connect the runtime components for persistence, messaging, security, and so forth. This also includes implementation and test skeletons that indicate the developer exactly where to put his work. So developers can concentrate on the what of a solution and not on the how of technology. FSW ensures a number of things: good developer productivity, the design and code of a solution match, creates consistency in the development model between solutions and services, and it encapsulates technology and proprietary APIs from your solution code, making it independent in the long run. FSW currently supports two programming languages and models: Java, Spring, and TypeScript, a JavaScript variant. And the engineering team might add more based on demand. Finally, every developer can choose his own IDE and working environment and tailor it to his needs. The CLI of IBM FSW integrates seamlessly in any workflow. On our little journey, we are now entering this area of innovation, which is full of existing and rapidly developing technologies and components. This ranges from pipelines for automated build, test, and deployment to container-based runtime environments. Here, IBM FSW consistently uses open source components that have been selected and integrated by the IBM team for their relevant capabilities and according to best practices, market relevance, and maturity. This is why we call it a curated platform. But IBM FSW is also open to be tailored to your needs. This means two things. If you have other requirements for foundation components or have already made a choice different from the ones we selected, you can adapt the platform accordingly. When innovation in the cloud-native environment produces better alternatives in the future, we adapt them and you can stay up to date without any effort on your side. As said, for all steps in pipelining and for the runtime, cloud-native open source components are used consistently. So what is the added value of IBM FSW if there are actually no proprietary components of its own involved? Quite simply, the platform ensures compliance with best practices, lessons learned, and current architectural patterns across all components it builds on, such as Kafka, MongoDB, Keycloak, Tekton, OpenShift, and many more. The engineering team behind IBM FSW ensures that topics such as logging, tracing, security, and scalability are robustly implemented throughout, saving you the time and effort to get started. We finally reached the end of our journey, and I would be very happy if you have got a good idea. Please let me take a few more moments to summarize. IBM FSW runs everywhere, on-premise and in all the cloud environments where IBM OpenShift is available, and that is practically everywhere. IBM FSW itself consistently uses cloud-native and open-source components and provides a curated selection of pre-integrated foundation components so that your solutions can take advantage of all the benefits but do not create dependencies. The relevant and proven IT patterns are already implemented, and a good number of code reference architectures and methods are applied in an easy-to-use way. This includes domain-driven design, hexagonal architecture, DevOps, and GitOps. For this purpose, the analyst uses the browser-based designer, the developer uses the command line interface, which triggers the code generators to create executable microservices for the curated open-source runtime. FSW offers an end-to-end support to turn business requirements into operational microservices in a controlled and effective process. All this is kept together by the pipeline, which is open to your requirements and adaptations. Well, all this packaged together is the IBM Financial Services Workbench. With IBM Cloud Satellite, their provisioning can be implemented extremely flexible across cloud boundaries. But that is a story for another day. So what are the core values of the IBM Financial Services Workbench? There are three. It makes cloud native usable, and this from a standing start without long preparation time according to best practices and future-proof. IBM FSW ensures that solutions are coherent and follow the current and correct architectural principles, and that you have the right design. Above all, it ensures that cloud native can be successfully and easily implemented by everyone in your company's IT. Not only from the always too few full-stack developers, but also and especially from the designers and developers who have used Java, C++, COBOL and SQL so far, but who above all have the experience and know how your business and IT works. We take them with us on this journey. So, you got an impression of how IBM Financial Services Workbench helps design and develop solutions and use them as microservices quickly and across your entire organization. Think about the adoption factors we discussed at the beginning. With fast time to market, good ROI, for little prior knowledge and experience in cloud native, and with enterprise-wide scale. I hope I made you curious. We look forward to hear from you.